Welcome back in submodule 1.4, that is error correction via HARQ and logical channel priority. Okay, so let's move on. So first we will discuss about the error correction via HARQ, how it is possible. As I have explained you, first our job is to identify the keyword, and here keyword is error correction. In this case, error correction, how error is corrected in case any error comes. So correction will come in picture when there is a error, otherwise no issue, right? Next is HARQ, hybrid automatic repeat request. So there is a term called ARQ and this term is HARQ. So let's try to understand that how error correction will be triggered in case there is any error comes between UE to the G node B. Okay, so first let's try to understand the layman language concept of the HARQ and then we will proceed in terms of technicality. Okay, so let's see that hello. Okay, let's HELLO. Okay, here is the transmitter. This is, let's assume that transmitter is G node B. Okay, and it has transmitted the entire packet to the receiver. In this case, receiver is UE. Assume the hypothetical scenario, it could be, you can reverse as well. H is transmitted successfully, then E is transmitted successfully and also successfully decoded on the receiver side. Then next is L, also done successfully. Now next is L. This L is also transmitted, but due to some reason it is not successfully transmitted, or we can say that this L is missed or lost somewhere. It could be on the air interface. It could also be possible that it logged on the stack, but somewhere the receiver stack or UE stack could not be able to decode it. So it could be a multiple scenario that is part of the troubleshooting. Okay, now next is O is transmitted and successfully decoded here. So what is happening here? Only this L is missed to decode by the receiver. Now what should be the receiver behavior here? Does receiver will ask, this receiver will send the NAC and ask transmitter to retransmit entire packet, or it will ask that only the missing packet, right? In case of HARQ, transmit receiver will ask only the missing packet to retransmit to the transmitter, not to the all. So what it will does, it will keep in the buffer all the successful. This is my receiver buffer, RX buffer. It will keep H, it will keep E, it will keep L, it will keep O, and will send NAC for the this L, and then once the transmitter receive the NAC, it will retransmit it further. So L will be retransmitted here. Once it received at the receiver end, right, what will be the process? There will be a soft combining process. We call the soft combining. What does it mean by soft combining? Means we have the old data set plus the retransmitted packet. It will be do the soft combining and then we'll see whether it has successfully able to recovered or not, right? So this is how the layman language you can understand it, the HARQ procedure. Now let's go on the technical chart. So example, G node B send the TB1 to the UE. So what does it mean? It means we are talking about the downlink scenario, because here is the G node B, here is my UE, and we are talking this direction data. So G node B send TB1, G node B send TB1, where the transport block is constructed, MAC layer. Now step 2, UE fails to decode. UE fails to decode and send the NAC. So UE will send the NAC to the G node B. UE will send the NAC to the G node B. Now what G node B will do? G node B will retransmits the TB1 with incremental redundancy. Incremental redundancy. What does it mean? Incremental redundancy means it will add the mode protection bit on the retransmitted data or the packet, so that Once the receiver receive it, in this case receiver is UE, the chances of successfully decoding of the data goes up. That is the what the purpose of incremental redundancy is there. Okay, so you have must seen it in the log. We have the RB0, we have the RB1, we have the RB2, we have the RB3. So these are redundancy version. With each retransmission, the version is going to be increased, means we are now adding the more protection bit to ensure that data successfully received and successfully decoded, right? So once it is done, what is happening? UE, which is receiver in our case, combines the original and the retransmitted data and the successfully decoding triggers, right? So this is the successful case, but there could be another case as well possible. So let's say even the combining is done, soft combining is done here with the old set of data plus the retransmitted. And what will happen? Let's say that this time also fail. Then again same process will trigger. NAC will goes, again incremental redundancy will be done for the next retransmitted and it will go on. If still let's say that max HARQ retransmission uplink and downlink, which we define it on the gnode beside, this is cell level parameter. Let's say we have said 8 times, and it in case it hits the 8 times, what will happen? The entire MAC SDU, your MAC SDU will be discarded and reset. Discarded and the reset, and in this case what will happen? In this case what will happen? Your RLF may trigger. RLF may trigger. So these are the different scenario could be possible, which we can see in the log, or you may see in your network that what are the possibility, but the concept wise is same, it will work. Okay, now let's see that logical channel priority. Logical channel priority, what does it mean? So let's try to do with that. So let me erase the data first. So I'm going to delete, and let's proceed it. So okay, so next is logical channel prioritization. What does it mean by channel prioritization? So let's understand it. MAC here prioritize the data from the logical channel based on what criteria? QoS, quality of service. Quality of service. So let's take the example. We have the traffic channel that carrying the voice over IP, and this is having the highest priority as we know. Compared to the, there is another dedicated traffic channel which carry the email, or which is having the priority 3. So this channel carrying the less priority services, and this channel number 1 carrying the highest priority services, which is voice over IP. So what should be the behavior of the MAC? What should be the behavior of the MAC? Okay, so MAC will prioritize in this case. How it will be prioritized? Based on the priority of the traffic. Based on the priority of the traffic, right? It will see that whether it is GVR services or non-GVR services. If there are GVR services, then what is the priority is defined by as per the 3GPP. If there is a non-GVR services, then among the non-GVR, which one is having the highest priority? So based on all these permutation and combination, it will take finally decision that which one grant has to be allocated first. Which one grant has to be allocated? So MAC send all VoIP data first. So first priority will given to here due to the high priority. Okay. Then email data is sent only if resource remains. So still, if there is a resource is available, then this resource will be aligned or allocated to this one. If there is no resource, it has to wait. It has to wait for their turn. Okay, so this is how logical channel prioritization triggers. Thank you. See you in the next submodule.